Greeting Dr. Honey. I'm Liong Xiang with my group members Chia Jun, Chu Yan Win, Ong Bo Quan, and Wong Teng. We are here to present our project Noise Pollution Control. Let us start with introduction. So, what is noise pollution? Noise pollution is sound that created by human, animal, or machine which is excessive, displeasing that disrupt the activities and balance of human or animal lives by causing psychological disturbance to living things. So, noise pollution brings different types of health hazards. However, people are not conscious enough about the topic noise pollution as is needed. This is because noise pollution exists as a type of energy which is invisible and brings indirect effect to us. Then, loudness can be represented by sound pressure level and act as measurement of noise pollution which is in decibel dB. Normal human ears, we can only detect sound from 0 decibels to 140 decibels, but sound beyond 120 decibels will cause pain to human ears or even cause physical damage to the eardrum. When we expose to some condition like the condition which is more than 85 decibels in a longer period, this will result in temporary or even permanently hearing loss. Therefore, control and confine of noise is needed to reduce noise pollution. So we use noise mapping method to control the noise pollution. It's a method which shows noise level of an area on a map through different color-based area. It is the process of identification of noise source. So in our project, our testing site is River Engineering and Urban Drainage Research Center, REDAC in University Science Malaysia Engineering Campus. This project is carried out to know the noise level at the research center and generate a noise map using ArcGIS software. And lastly, the results obtained are discussed and compared with third edition of Guideline for Environment Noise Limit and Control 2009. So for our objective, we try to apply sound level meter correctly, determine LAQ's equivalent sound pressure level, produce a noise map, analyze and compare the result with the REDAC guideline, study causes of noises and suggest ways to reduce noises at our study area.
Greetings to Dr. Herney, I'm Chia Jun. Our research was carried out at REDAC. This decision was reached through a vote among the group members. We are using 10 reference points, which allow the REDAC to get the sound level pressure. Since we are choosing public holiday for our data collecting, we are only heard the sound of river swimming and birds singing. The sound level pressure is measured by a sound level meter, as you can see from the slide. Before and after collecting the data, we must calibrate the sound level meter to ensure it is free from errors. As you can see from the slide, here is the calibrator which used to calibrate the data, and here is the microphone we used to record the sound, and here is the windshield which used to protect the microphone. When taking the data, there are two precautions must be taken into consideration. First is do not talk to other group members when taking the data. Second is do not produce any unwanted sound from any human action like whispering, clapping the hand or crouching. Now we talk about the procedure. First of all, we stand 3 meters to 4 meters away from the target area, which is the REDAC center. Secondly, we insert the microphone on the sound level meter by turning it in clockwise direction. After that, we insert the calibrator on the microphone to make the calibration. After calibration done, we remove the calibrator and insert the windshield to protect the microphone. Next, we record the data we get for every 30 seconds. After that, we do the calibration again after the data for each reference point is recorded. We change to next reference point after 6 minutes immediately to prevent loss of time. Last but not least, we repeat the step 3 to 7 until the data from the all reference points have been recorded.
I'm Wong and I will be presenting the results for this project. As shown, data are collected from readout USM at the following coordinates from 9:30 to 10:30 morning using the methodology mentioned before. Point 1 has 4 peaks, 2 at 180 and 240 seconds timestamp due to the passing by of cars, and 2 at 300 and 330 seconds timestamp due to the motorcycles passing by. Point 2 has 3 peaks, which the earlier 2 is due to cars at 420 and 480 seconds timestamp and the motorcycle passed by at 690 seconds. Point 3 is at ambient situations. As point 4 is near to an air conditioner of the facility, it presents a louder and higher overall sound level. Point 5 is at ambient situations. Point 6 is also at ambient situations, but there are 2 peaks at 1830 and 1860 seconds timestamp due to a local airplane. Point 7 is overall louder as it is near to a machinery and hence a higher overall sound level. Point 8 is at ambient situations. Point 9 has 2 peaks at 2970 and 3240 second timestamps due to a bird chirping at that instance. Point 10 is near to the road connected to the hostel and hence has 3 peaks at 3270, 3300 and 3420 second timestamps due to car noises. Descending order of dBA and frequency are then recorded, and repeated readings are written as 1 with the frequency listed beside. Each point has 12 readings 30 seconds apart, means that we have a total of 130 readings, and the total percentage of 100% is added up to confirm that the result tallies. The frequency are later stacked to find a cumulative percentage for later use. From the above data, we can use it to plot the graph of noise level with respect to time and a cumulative frequency curve with respect to noise level. LEQ, in other words, equivalent continuous sound level that is calculated, is defined as the steady sound pressure level which, over a given period of time, has the same total energy as the actual fluctuating noise. Thus, the LEQ is in fact the root mean square sound level, which the measurement duration is used as an averaging time. The LEQ is calculated using a formula as shown, and we obtain 53.03 dBA for the whole area. The L90 is a statistical descriptor of the sound level exceeded 90% of the time of the measurement period. It is the same for L10 and L50 with varying percentages. L10, 50 and 90 are obtained by connecting a line from 90%, 50%, 10% of the cumulative frequency to the corresponding noise levels, and 57.4, 46.5, 40.3 dBA are obtained for these 3 values respectively. Similarly, these steps are repeated for all 10 individual points, and we will get what is shown in this slide. LEQ is highest at point 1 followed by point 4. L90 and L50 are the highest for point 4, which corresponds to the high continuous sound levels in this area. L10 at point 1 is the highest due to the occasional car passing by the area, which causes sound level fluctuations. This can be represented in a visual form using EAP software, and as shown, point 1, 2 and 10 that is nearer to the roadside experience higher sound levels, and at point 4, the sound produced by the air conditioning systems also contributes to noise pollution around its radius.
Greetings, Dr. Herney. I'm Ong Bo Quan and would like to present my part about the discussion of our project on the noise pollution measurement. The area of our study is a low-density residential noise-sensitive receptors institution, which normally are the school, hospital, and workshops. The location of our study is the REDAC of USM Engineering campus. Date and time of our project carried out is on the 6th June 2022 from 9:30 AM to 10:30 AM. The application used to determine the noise map of our study location is by using ArcGIS, and we determine all the values regarding to the guideline for environmental noise limits and control, 3rd edition 2019. And the formula used to determine the value required is as shown as the slide. The overall result obtained from our project is as shown in the table. The LAQ value of our study area is 53.03 decibel, L10 value is 57.4 decibel, L50 value is 46.5 decibel, and L90 value is 40.3 decibel. The standard daytime LAQ is equal to 60 decibel based on the second schedule of the guidelines. Based on the general perception of sound loudness, 20 decibel is reasonable, 40 decibel is the average home noise, 60 decibel is the normal conversation, 80 decibel is the level at which sound becomes physically painful and can be harmful if the sound level is above 85 decibel. Based on the equivalent continuous sound level we obtain, mentioned study area can be defined as exposing to medium noise level due to the obtained value is close to the average value of daytime noise level of residential areas, which shows that the mentioned study area is safe from harmful noise pollution. Based on the published guidelines on the noise exposure levels from World Health Organization WHO 1980, the recommended maximum LQ level is 55 decibel and the data obtained from our study areas is 53.03 decibel, which is below the recommended maximum level. Based on the data obtained, L10 of 57.4 decibel is obtained and is used to measure the maximum noise level. In other words, noise level exceeds 57.4 decibel for 10% and lasts for 6 minutes in an hour. L50 of 46.5 decibel is obtained, which indicates 50% of the measuring time, which is 30 minutes in an hour. The noise level exceeds 46.5 decibel. 90% of the measuring time, which is 54 minutes in an hour. The noise level at our study area exceeds 40.3 decibel, which is known as L90. The study area is considered as quiet environment with limited noise due to the data of the sound measurement activity carried out is a public holiday where there is very limited person who is in the laboratory carrying that work. Noise map as shown in the slide is obtained where point 1 and 4 of our study areas is in the red zones with the LAQ value in the range of 55 to 58 decibel, where the location is in the zone might possess to noise pollution. Point 2 and 10 are in the orange zone with LAQ of 52 to 55 decibel, and point 3, 5, 6, 7, 8 and 9 are in the green zone with LAQ of 40 to 43 decibel, where these two zones are with low noise levels, which is safe from exposing to noise pollution. Sources of the air pollution in our study area might be caused of the vehicles passing by the adjacent roads such as cars and motorcycles, noises from aircrafts passing by above, air conditioner buzzing noises, machinery humming noises, and bird chirping noises. There are several ways to overcome the noise pollution in the study area. The adoption of electric vehicle or hybrid vehicle that could produce lesser noise as compared to the vehicles with an internal combustion engine should be done. Improvement on road surface properties by using quiet road surface, which help in reducing noise pollution. Noise barriers can be implemented to the boundary of the area to reduce the impact of the noise to the area. Implementation of the zone controls and the other lane use policies to limit the noise from the air conditioners. Planting of trees and vegetations can help with reducing the noise levels as well. That's all from me. Thank you.
My name is Chu Yan Win, metric number 145485, and I will conclude for this project. So, noise pollution is the excessive, displeasing environmental noise and unwanted sound that disrupts one's quality of life. It penetrates the environment and is irritating to one's ear, which comes from an external source. The source of noise pollution can normally be found in many places such as road traffic, aircraft, construction sites, and from consumer products such as air conditioner and loudspeakers, but it also comes from many industrial facilities and buildings. For this project, the selected site testing site is at the River Engineering and Urban Drainage Research Center (REDAC) at the USM Engineering campus. The objective of the project is to determine the major noise level and the corresponding noise source in the study area and make a comparison between the results obtained and the guidelines with the guidelines for Environment Noise Limits and Control 3rd edition 2019. There are three major procedures that are being implemented in this project. The procedures are the measurement site selection, measuring equipment, and measurement procedures. Based on the acquired result, the LEQ calculated is 53.030 decibels. When compared with the guidelines and for environment noise limits and the control 3rd edition 2019, Schedule 2 and World Health Organization, our result of LEQ value is abide within the range of safe limit and residence. After some calculations are completed, the L10, L50 and L90 are tabulated in the table shown in this slide. From the noise mapping, there are two higher noise level regions, one located at the sampling point P1 and another is located at the sampling point P4, which both are in the red zone of LEQ of 55 to 58 decibels. During the study period, the corresponding noise sources identified are including the noise from cars and motorcycles passing the adjacent road, conversation between friends, chirping of birds and insects, air conditioner buzzing noise, noise from aircraft passing by above, and machinery humming noises. The things that can be digested from the project is that the noise level is in the study area does not exceed any limit in the guideline. Nonetheless, any future development in the study area that become attractions must be considered, since the noise from construction and the noise from operating equipment will be the main issue of the noise pollution. Hence, the prerequisite approaches such as adoption of equipment and that emits less noise and less vibration should be implemented. Furthermore, constructing noise barriers and plants trees and vegetations with the intention to absorb the noise generated can also be suggestions to be considered. In conclusion, we have acquired a lot of knowledge and practical skills regarding the noise pollution indication, starting from the measurement technique at the site to the calculation and analysis of the result obtained. The identification of the noise source generated in the surrounding environment is indeed crucial to know the contributing factor to the noise pollution so that the respective mitigation measures can be implemented prior to the main issue. This is also important as the reference of the developer in terms of the implementation of the preventive approaches to minimize the noise pollution produced from the traffic as well as the construction activities. That's all from me. Thank you.